Yeah. Anybody from geography department, are you able to connect with the dignitaries? Yeah. So we are in the session 18. This is last technical session and is going to be relayed online. I'm waiting for dignitaries to join because session is late. Sir, please
Ma'am,
join the meeting. Yeah,
ma'am,
please
please
join the
start.
meeting.
Ma'am, please start.
Yeah, yeah. The technical session. Like I'm a coordinator, but then guests have to join. Sir, please join. Hello.
Okay, ma'am.
Huh. So I feel I should be in. Maybe there is some confusion. We are waiting for technical session chair and co-chair and these people to join. Munir Khan sir. I'm sending messages to them. Let's hope they join in time.
It's okay, ma'am. We will wait.
Yeah. No, because session is delayed, I don't know. Maybe they didn't get the update, right?
Yeah, ma'am.
And
The
maybe
link
the
is
link,
not.
and what happened because session got delayed and people joined earlier session and the session ended, so many people might have little confusion. So we have got to discount the time as well as understand that there can be a confusion,
Yeah, ma'am.
right? Just a minute. Quickly, I'm sending messages to everybody. Jiba Raj, are you there? Yeah, dignitaries, if you're there, you please unmute and tell us if you're there, that so that we can start. Munir Khan. Yes. Yeah. Have people joined? Yeah, I'm requesting Jiba Pokhrel sir, Munir Khan sir, Upreti sir, Sohana sir, Lal Rindikika, and Mohammad Soel Mir sir. If you're there, please unmute yourself. I invite you to for this session. Not able to find anybody. 1 minute. Somebody from geography department, can you connect with me quickly?
Okay, ma'am.
Yeah. Just call me. See, there is some confusion because of the technical session got delayed, and hello. So because of which we can to save the time and see that the Zoom links don't get exhausted. As a session coordinator, I've got to take some call. Whoever is present from dignitaries will speak, and we will give them chance as soon as they arrive. But meanwhile, we will not delay the presentations because Zoom link will get exhausted, right? So anybody from dignitaries, are you there? So please let me know if you're there. I'm not able to, find uh, people individually. I once again I asked if you're there. Please let me know. Yeah, Pokhrel sir, are you
Yeah,
there?
Dr. Sohail
Munir,
is here.
Dr. Soel. Okay, great to have you, sir. Munir Khan sir, then Upreti sir, Sahana sir, Lalrika, and sir Mohammed Soel Mir, Dr. Mohammed Soel Mir. You're there,
Yeah,
right?
I am there. I am there.
You're a rapporteur, right? So you will be reporting. Yeah, yeah. Good to have you. So I request we will start with the
Yeah,
presentation,
yeah.
I guess, and then when the technical session chairs and the dignitaries will join, we will, take up their session. So we have great dignitaries. We have international figures, and they're great. I can quickly say that we have Dr. Jiba Raj Pokhrel sir, and he is an internationally known member. And because we have, and then also we have Munir Hayat Khan is also from international, and Nath Upreti sir, Vishal Nath Upreti sir. And so as soon as they join, we can accommodate them. And Mehboob Sahana sir. Okay, so we will take up the first presenter. Is that okay? Yeah. Yeah. Hello.
Yeah, you can start, ma'am. Yeah, please start.
That's okay, Soel sir? Yeah,
Yeah,
so
yeah,
should
you
we
can
consult
start.
Jayanta sir once?
Yeah, yeah.
We start, that's okay?
Sure. Yeah, we
Okay,
start.
thank you so much. Okay, so the first presenter, Rinkimi, are you people there? Then Riaz Sharif.
Yeah, I'm there, ma'am.
Yeah, Riaz sir, can you start, please? Go ahead. We allot 5 minutes to each presenter so that when technical session people join, we should accommodate them. Okay, thank you. In crisis, and because of which we are just starting without dignitaries have joined yet. Okay, thank you. Riaz sir, please start.
Yeah, ma'am. Let me start. I'll share my screen.
Yes, I think you can start. Yeah, you can share.
You can see my screen as well.
Yes,
Yeah.
yes, yes. Wonderful.
Yeah.
Yes.
So, good afternoon, all. Let me introduce myself. I'm Riyaz Sharif. I'm the author of this paper, and on the topic investigating the interplay of LST, NDBA, and NDBA on nitrogen dioxide and carbon monoxide pollution in Kolkata city, India. It's a multi-year geospatial analysis using advanced remote sensing technique, and I'm thanking Department of Geography Rampurhat College for organizing this. So, about me, I'm working as a project associate at Salim Ali Center for Ornithology and Natural History, and my research focus on air pollution monitoring, urban dynamics and forest dynamics and climate change. So let's dive into the topic. So these are the table of contents. There are introduction, which focus on the significance and context of the study, and we have a research objective, which aims on the goals of the research, and we got the data sets which are used for the analysis, and the methodology, which is the important part, which focus on the techniques we use for the analysis and the results, focus on the visualization of our study. And at last, we will be having a conclusion stating the problems and the solutions for the research.
Hello, please unmute yourself.
No, ma'am, you can get it. Hello?
Yes, we
Sorry,
can
bro,
now
we
hear you.
Oh,
cannot.
sorry.
Please go on.
Can't able to hear. Let me start from the beginning. I'm sorry. Sorry from my
No,
side.
no need. You just got unmute for just a while. So no
Yeah,
need.
yeah.
You can start. No problem. You can continue and take another 2-3 minutes.
Yeah. So this is the introduction. So the introduction part plays that how the pollution is linked with climate change, and the health impacts of the air pollution is very big. We can see that about 6.7 million deaths are happening worldwide, and it happened in 2019, and it is being increased for upcoming years. And the role of environmental facts plays a major role in air pollution, and which are I am taken into the studies are land surface temperature, vegetation index, and build-up index for the study, and it is mainly focused on how the urbanization plays a part for air pollution. So this is the study area I'm having. This is Kolkata region. I have chosen in the West Bengal area. So next is a research objective. So totally we have 4 objectives for the study. So how the NO2 and SEO concentration vary spatially and temporally, and how the impact of LST on the level of pollutants, and how the vegetation cover and the built-up index affect the pollution distribution, and how all these insights play a role in urban planning and strategies. So data sets, for the data sets, I've been using satellite data to access the spatial and temporal variations, and so these are the data sets. So for geospatial analysis, I have used Google Earth Engine, and for nitrogen oxide and carbon monoxide, I have used Sentinel 5P data of tropospheric monitoring instrument. It is a sensor used for collecting the radiations of pollutants, and the land surface temperature NDVI and NDPI used to Landsat 8 data of resolution of 100 meter, 30 meter, 30 and respectively. So the methodology, there are two statistical methodology, bivariate analysis and a linear regression model I've used to support my result. So these are the notes of bivariate analysis and linear regression model. So bivariate analysis actually plays a relationship between the two distinct variables. In this, I have taken the variables of LST and DV and DPI in one part, and the main part of
Riaz,
CO2 and CO2.
hello.
Yeah,
Riaz, your slide is not changing. Can you go slide mode? Now it is changing. Yeah, now it is okay.
yeah, yeah.
Now it is okay.
So
You can proceed.
yeah.
Can you please move to conclusion? We have session dignitaries who have joined and wish to present because there's something else it seems. Okay. Can you just
Yeah.
conclude?
Yeah.
Huh?
So let me show the visualization. This is the visualization of the NO2, CO, and NDVA LST of Kolkata. And this is the main part, the scatter plot. In this scatter plot, this is nitrogen oxide with LST. We can see the consistent changes in that, but actually the trend line is showing a positive correlation, which means that when the LST is high, land surface temperature is high, the NO2 is also high. So let me get to NDVA. So NDVA part, when the scatter plot trend line shows the downward angle, which shows that NDVA is not correlating with NO2, means
Please
that
conclude here. Please conclude. Huh?
yeah. So let me get back to this bivariate analysis map. I have been prepared for this analysis for NO2, the LST, NDVI, NDPI, and LST, NDVI, and NDPI. So the overall result shows that LST and build-up index have a more influence on NO2, and the NDV doesn't have a good correlation with the NO2 or CO, because that the city doesn't have a vegetation cover, that much vegetation cover to absorb the pollutants. So this concludes the support of my results, which shows that we need more vegetation cover in the urban areas to get to know that vegetation absorbs the pollution, so the urban areas will be free from air pollutants like NO2 and carbon
Yes.
monoxide.
Thank you. Thank you.
So
Yeah. Thank you
so
so
this
much.
is yeah.
Yeah.
So this is the conclusion part, and let me finish this. Just give me 1 minute for this. So these are the 5 ideas I have: integrated urban planning and control measures and technology and collaboration, and the importance of vegetation, and how the public awareness would be the major part in that. So and actually the China actually made a quite possible thing on war on pollution, which made them to decrease their pollution quite amount, like 42% overall, and the 50% in their main city of Beijing from 2013 to this day. So we can take this as an example, so we can use it in places like Delhi or like high pollution cities of India. So this
Thank you
will
so
get
much.
to me
Thank
as
you
a
so much.
last.
Yeah.
Yeah.
We have Upreti sir. We welcome him, and I can see Lalrindika sir also. So, ma'am, I'm not able to understand the name. Okay, so now it's our honor that sir has joined. So, Upreti sir, welcome. He's an eminent geoscientist and academic leader with specialization in structural geography, geology, and his distinguished career spanning of more than 4 decades, and he was a professor, including full professor at University of Zambia, and been in also in Nepal, where he served as the dean of the Institute of Science and Technology. So, if it's an honor actually to go on, having him for this session. I welcome you, sir. There was a crisis management. I'm sorry. In fact, the dignitaries, because of the time zone being different, we are not able to have all of them at the same time. There's slight joining one after another, and also because of technical glitch, there had been some, some people, there is people are getting logged off and rejoining. I welcome you, sir. Kindly present your thoughts in 10 minutes. Thank you so much. Sir, can you listen to me? Hello. I saw sir was there. Upreti sir. Oh my God. You got logged off? He just told me that he is joining.
Should I stay or I have to log
1 minute.
out?
Yeah, you can stop your presentation, Sharif sir. Yeah. So yeah,
Hello.
yes, yes sir. So can we have Lal Rindika sir is there?
Yeah, Riaz, you have
Hello.
completed.
Can't hear you. There is hello. Can't hear you. Hello. Do
Hello.
we have dignitaries? Hello.
Hello.
Hello. Pokhral sir, are you there? Munir Hayat Khan, are you there? Then
Yeah, Riaz, have
yeah,
you
Vishal Nath
completed?
Upreti sir. Yeah, he is completed. But are you there, Mehboob Sahana sir, or Upreti sir? I saw them; they were there. Again, got all logged off, I guess. So I thought as soon as dignitaries will join, we will allow them to speak for some time, and then we will continue with the presentation. So, if dignitaries, are you there? You please present. I can't see again. Somebody got logged off. I think there is a problem. So, can we go ahead with the next presenter, Rinkimi? I think next presenter is Lal Rinkimi. Hello. Who's the next presenter? Who's ready with the presentation?
Yeah, yeah.
Lal Rinki. Yeah, yeah. Please go ahead with, because Sharif was second. We allowed him
Yeah,
because we
proceed,
need
ma'am,
more
proceed.
time. Proceed, Lal Rinki. Please proceed. Proceed. Thank you. Yeah, please go ahead. Take 5 minutes. Present main points like what was your objective, your findings and conclusion quickly. Yes, start your presentation. Hello. Can't hear you. Hello. Quickly. Next presenter, please be ready. Met it. After that, Raja. After that, Haq.
Ma'am, give them
Yusufullah.
near
Then.
about minimum 10 minutes so that they will complete
Okay.
comfortably. Otherwise,
Okay.
they have
No
worked
problem.
very
Happy.
hard.
Yeah, understood. Okay, fine. Please start your presentation. Please unmute yourself. Please speak. Yeah, what is the problem? Hello. You need any help? Lal Rinkimi, is there any help needed? Please let us know because we can't hear you. Riaz Sharif sir, sorry, if we have a time towards the end, we will give you time. Don't worry, please don't worry. Towards the end, we will allow you to present again. In case, see, we are just, it's a crisis management. I'm sorry, but then Lal Rinkimi sir, please present your presentation. Yeah, Sharif sir, please wait. We will allow you. Don't worry. Yeah, don't worry. There is no voice. Hello, Lal Rinki miss. Please speak. We can't hear you. Hello. Be a little louder. Please unmute yourself. Hello.
Hello, ma'am.
Yes. Happy to have you. Please go ahead with the
Okay.
presentation. Yeah, please go ahead.
The peak hour in the morning is 9 to 11 a.m. and in the evening it is 3 to 5 p.m. in the evening.
Please take 10 minutes. Okay.
Okay.
Please take 10 minutes. We have to, first presenter was given a little less time. So we are going to allow first presenter again sometime in the end. Thank you.
Here I have some of the important traffic congestion, traffic junctions in Aizawl City. Each day in a week, the traffic volume was counted here. I will move on here. And the diagram shows that 83.6% of the questionnaire responded used to travel 5 to 6 days a week to their regular destination, while their most their they used to travel by their own two-wheeler. That is their most choice. And here is the diagram represent the parking lots as well as the bus stop in the city area. From the questionnaire, it is clear that majority, more than half of the questionnaire responded have a proper parking in the working at their workplace as well as their residence. And from the questionnaire, it is clear that roadside parking is an issue for traffic congestion within the city, where 95% of the questionnaire respondent says that roadside parking is issue for traffic congestion. And the government also take actions regarding to control the traffic congestion within the city. And there is a rotational vehicle movement based on their two endings registration number, which was started in 2017, which was and it was followed till today. Some of the findings include that the study um, observed that the traffic congestion was identified during the peak hour of 9 to 10 a.m. and 3 to 5 p.m. At various important junctions within the city. And during this peak hour, school, office, and daily workers are commuting to and from their workplace. And among the mode of mobility, such as shared vehicles, private vehicles, and pedestrian walking, more than 80% of the commuters preferred private vehicles. And these preferences is due to the convenience as per the requirement, the need to avoid crowd and traffic congestion, saving time as well as safety concerns. However, the shared mobility as well as the public transport are not available in all areas within the city. And also, the study revealed that roadside parking is one of the major causes of traffic congestion in Aizawl City. As we have already mentioned in the previous slides, that the government has also implemented rotational vehicle movement based on the ending registration, but this triggered the double-fold increase of vehicle, especially two-wheelers. And some of the suggestions have been made from the study. The first one is shifting of office hours, emphasizing public mode of transport, banned roadside parking, proper parking place, improvement in the pedestrian walking, proper and uniform passenger fares, introduce a new road like bypass road, and introduction of a new system of transport like Uber system in the city. Thank you.
Thank you so much for such a crisp presentation. That was very brilliant. Thank you so much. Yes. Do we have Upreti sir? He said he will join. He messaged me and he will speak for 3 or more minutes. I'm happy to have him, but again, I think got logged off. Dignitaries, if there, please. If not, the next presenter can start. We have any questions? Hello? If anybody has questions, please post to the presenter. And Riyaz Sharif sir, we will give you some more time little later. Towards the end, definitely we will listen to you. Sorry for, because I was getting messages from the dignitaries. So I thought they're in hurry to present. Any questions? Okay. Who's the next presenter wishes to join? Who's ready?
Ma'am, I'm ready.
Yeah, Metit. Yes. Welcome. So we have Kaman Metit. Please present your paper. Thank you.
Thank you, ma'am. Is my screen visible, ma'am? And audible?
Yes, yes, yes.
Good evening, everybody, dignitaries, including all the participants. My topic is water scarcity and urbanization in Northeast India. And I'm a research scholar from Department of Geography, Manipur University. And this is the introduction that water scarcity is an escalating issue in major cities all over the world, and including big cities, and in developing country also, this water scarcity is creating a problems. Rapid urbanizations in cities, in Indian cities, also in northern cities, this get pressures on water sources, leading to depletion, pollutions, and inadequate infrastructure. Then mainly, urban growth characterized by rising population density, uncontrolled settlement expansion, and industrialization has exaggerated the water stress and degraded the water qualities. And even also, climate change has also exaggerated this phenomenon. And from this perspective, the study is taken. And this is my study area. My study area is the entire Northeast India. And in terms of basin analysis, the Northeast India can be divided into three basins. One is Brahmaputra Basin, and number two, Barak and other basins, and number three, major river draining into Myanmar and Bangladesh basin. This classification is taken from CWC classifications, and these are my objectives. Objective number one, to assess the availability of water resource in Northeast India, and objective number two, to examine the relationship between urbanization and water scarcity in Northeast India, and last objective to analyze the causes of water scarcity in Northeast India and suggest sustainable solution. And this is my methodology, that I have collected data on water resource potential, surface water resources, life storage capacity of reservoir, groundwater resources, precipitation, transport, evaporation, natural water availability of Northeastern region, and calculated from state-wise statistics and basin-wise statistics. And this formula, water availability formula, has been used by this CWC to calculate water availability. And lastly, we calculate the per capita water availability and per capita utilizable water by dividing the water quantity by the total populations. And lastly, a correlation test is done to check the relationship. And this is the water resource potentials in the river basins of Northeast India. Here, the three basins, Brahmaputra, Barak, and the minor rivers. And in this the catchment area, Brahmaputra is very large, and in the average water resource potential, that Brahmaputra is in terms of this 527 BCM. BCM is billions cubic meters, and from this water potential, we can use only 24.00 BCM of this water, which is utilizable surface water resources. And next slide is surface water resources. This is set-wise, and this is given. And in the first column, there is the river and canals lengths are given. And from the second column, small reservoirs, medium and large reservoirs, tanks and ponds, that others in terms of areas are given. And in this table, we can see that Assam has the highest area of this water surface area, and lastly, this Arunachal Pradesh has the minimum. This area is excluding rivers and canals. And for this, and again, we are turning into the live storage capacity of reservoir, where the reservoir can hold how much amount of water can handle. And from this Brahmaputra basin, these two tables is from two perspectives. One is from basin perspective, and another is from the state perspective. And in the first table, we can see that Brahmaputra basin has 1.0 BCM capacity of water can be there in the reservoir, and Barak is only 0.72 BCM. This all total, and as in whole Northeast India, this is 2.58 BCM water are kept by reservoir. And in the second table, we can see that in the Northeast state, there are 5 state in which the live storage capacity is very much low in Assam. This is very concerning, because Assam has a large Brahmaputra river, and we cannot store this much water. And this is, we need to build dams in the sideways of the Brahmaputra river. And this is the groundwater resources table. Here, this is the state, and there are annual reference several groundwater resources, where we are collecting groundwaters from the rainfalls and other sources. And here I classify into this monsoon season and non-monsoon season, where this total we get here in the totals column. And this what we require to estimate is that the normal discharge during non-monsoon season. In the monsoon season, when the rainfall is occurring, that we don't need about this discharge from groundwaters. And in this column, normal discharge is important, because when the rainfall is off, and the quantity of groundwater extraction is increasing at the peak. So this is important. And for the whole Northeast India, 7.55 BCM of quantity of water is extracted this season. And by subtracting this, we can get net annual groundwater availability are state-wise. And from this, and we also understand that this is the last column, annual groundwater drought. This is the actual uses of water by this state as 2023. And this is the table that I made from assessment of water resource of India, CWC 2024. These three columns: precipitation, evaporation, evapotranspiration, natural, and water availability. And this are collected and plotted in this diagram, where we can see that there is, from the general conception, we are quite uh, opposite to what we see here. This is this blue line is the precipitation, and this green line is the water availability, and this red line is the transport evaporation natural. And this, we generally believe that when when rainfall may be the higher rate of this amount, but when we consider this data from this CWC data, we are getting this because uh, the water availability is more than this precipitation, because the major systems of the Northeast rivers holds a large amounts of water, so we can get water availability more than this precipitation. And this is the part we
Can
think is
connect with your
Next.
computer.
Next, kindly conclude.
okay. And this is the per capita water availability.
I cannot do this. I have to connect from the computer, not from here.
Yeah. We are happy to have Vishal sir, Uprati sir. Yeah, after just 2 minutes, and then you can present.
No,
sir.
that's okay. Please send that link to my email address. I cannot do it from my mobile.
Okay,
And
sorry,
I
sir.
cannot copy. Yeah, just to
don't worry.
send.
I
okay.
will send. You please,
Yeah.
you please
Okay,
send me your address to my
No,
WhatsApp.
I've already sent.
Okay,
sent.
I'll check. Yeah.
Okay. Yeah. Thanks.
Kindly conclude the presenter. Yeah.
Yeah. Thank you.
And this graph is the trend of water capacity, water per capita water availability of Northeast that here. In year 2021, we have around 15,000 cubic of water, and if this trend continue in 2026, this will reduce to 11,000 cubic. And this is most important, because water availability is not what we can consume, and this is per capita utilizer water is what we can consume. Here, I get this utilizer water 26.91 from the groundwater surface and the surface waters. So dividing this by the total populations, we get this data, and this data is in cubic. This per capita utilization waters. This Northeast India is decreasing, that in 2026, 468 cubic means 4,068 into thousands liters only we are getting, and this all. And this is the urbanization rate in Northeast India. And lastly, this is the correlation between the urban population and per capita water availability. Here, the results show that minus 0.87, that significant at 0.05 level, and this all. And the causes of water scarcity in Northeast India, these are the causes: that uneven and erratic rainfall, deforestation and land degradation, rapid urbanization and population growth, pollution of water resources, traditional farming practices, climate change and extreme weather events, inadequate infrastructure and governance. And these are the sustainable solutions that we can do to improve this, especially rainwater harvesting, afforestation and reforestation, integrated water resource management, improved irrigation facilities, pollution control and wastewater treatment, community-based water treatment, climate change mitigation and adaptation, policy and institutional reform. And this is my conclusion. Water scarcity in Northeast India, despite abundant water resources, arise from rapid urbanization, environmental degradation, and climate change. Factors such as uneven rainfall, deforestation, pollution, and inadequate infrastructure water stress, present farming practices, and insufficient water management for the critical issue. Addressing this requires sustainable strategies such as integrated water resource management, improved storage capacity, efficient water use, watershed protection, and upgraded infrastructure. Community participation and longer policy frameworks are also critical. Collaborative effort among the stakeholders are essential to mitigate water scarcity and preserve the region water resource for future generations. Thank you, ma'am.
Thank you so much. Any questions? We already have Uprati sir, and he can be there with us for 3 minutes or little more, he said. We welcome you, sir. If there are any
Thank
questions,
you.
yeah. If there are no questions, then we will welcome Uprati sir. We are eager to listen to you, sir.
How many minutes I get?
Sir, you get 10 minutes.
10
Yeah.
minutes.
Yeah.
I am
And we
prepared. I
can
am
be liberal
prepared
with
for
you.
20 minutes. Huh?
We can be liberal with you.
Yeah, sorry for that. I prepared for lead talk, and that was for 20 minutes. But anyway, now I open my file. Okay.
Thank you. Sir, you can take your time, but I mean, because we started a little late, so we have to curtail the times. Okay, please.
Okay. All
Yeah.
right.
Thank you. Thank you so much.
So
Welcome you.
can you see my slides?
No, not yet.
So where do I go? Share? Do I?
Yes. Below, you will have that screen share.
Let me
We have
see.
technical support. Hello. Technical
Oh yeah.
support, please help, sir. Geography department technical support is there.
Uh, yeah. Share. Okay, share, and then share. Okay, then
Yes, yes. We can see your.
now you can
Yeah,
get it, and
wonderful.
also
Yes,
you can see
yes,
the slides,
yes, sir. Yes, sir.
and
So,
then
yes.
do you
Yeah,
see
sir.
only one screen, or also you have the next screen? Only one
We are
screen.
seeing your full screen, sir. You can take
Okay, very
15
good.
minutes or little more, no problem. We're
Okay, thank
waiting for
you.
you. Thank you so much.
So, thank you. Yesterday, it was my talk on yesterday. Somehow there was a confusion. I want to talk about the earthquake hazards in the Eastern Himalaya, which has a direct bearing on the Bengal, West Bengal, from all the way from north to the south, almost up to Kolkata, or I don't know how far it will go, depending upon the size of the earthquake. So this is my presentation based on the work that has been done almost up to 2024 and all the way up to 40 years of research. So we are very much concerned about the earthquakes as well as Eastern Nepal and Western Nepal. Western Nepal and India, we could say these two particularly all the way up to Dehradun from Nepal border. You can say, Uttarakhand and Himachal. So as well as in the east, I would say from Kosi River towards east. And most importantly, it is the Eastern Nepal, Darjeeling, and Sikkim, west of Bhutan and east of Koshi River. This area is supposed to be very vulnerable right now. If anything happens there, it will be a big disaster, not only in the Himalayan region in the north, but also in the plains. So that is why we are so much concerned, and we need a real preparation right now. People think that, well, we are in the plains far from the Himalaya, there's no earthquake. It's not true. Even for West Bengal, it is really, really, a concern. And particularly we who are working on this field right now are really concerned about it. You see, we are looking at this map of Asia, and you can see Dhaka and Kolkata will be just nearby. And you see these red marks are all highly sensitive zones for earthquakes. And you can see the darker the color, that means more dangerous. But yellow is not a safe place. You see, its shaking is very strong even there. And more closer view, you can see here the red marks and the dark red and light red and pink. So we are all in a very, very highly seismic zone, and we are expecting big earthquakes in the eastern part. Of course, the most earthquakes originate in the Himalaya, but they affect not only the Himalayan people, but its damaging effects are also felt in the immediate surrounding regions, including the Indo-Gangetic Plains in the south, as far as Delhi and Lucknow in the west, and Patna, Kolkata, and Assam in the east, depending upon where you have the earthquake. If it is in the east, it will be Kolkata, Assam, whereas in the west, if you have, then you have, Delhi and Lucknow and, a lot of these areas. Therefore, it's a common problem, and the mountain region in the north and the plains in the south have to work together, and we should be all prepared for this earthquake. we started working in Nepal in 1978 with the first seismometers. In India, it is long time before that you had these studies done. But I would say that the last 40 years, 42 years of studies in the Nepal Himalaya has been so rigorous, so consistent, so well, organized way that the knowledge that we have today about the Himalaya, the seismotectonics and the possibilities of earthquakes, that all comes, the basic knowledge comes from the Himalaya, Nepal Himalaya, which was, has been constantly being worked in for the last 40 years. So because of that, we are more knowledgeable about what is going on inside the earth and what is the potentiality of the earthquake. I don't want to go into that because I don't have time. That this is 50 to 60 million years before India collided with Asia, and then the earthquake started occurring since that time, and it will continue for another millions of years. So that if you have one earthquake, this is all. It's not true. It is a repetitive process. Today, India moves to the north at a speed of 4 centimeters per year, and that pushes the rocks, and then stores the energy, and that energy is released, and we have the earthquake. So it is not one-time event. It is repeatedly, continuously building up the energy and releasing of the energy. Just for those who are not from the geology field, I just wanted to have this small see, in between we had the sea, what we call Tethys Sea. India was moving, Indian plate was moving to the north, rammed with the Eurasian plate, and then you see how it is continuing, and then producing Himalaya, Tibet, and and what happened during this process is that Indian plate is I have to laser pointer. So you see that Indian plate is kind of sliced, and along these slices, along these faults, all these earthquakes occur. So this is what is very quickly I wanted to say. And also this red part is Indian plate, and the yellow part is the Eurasian plate. And we have a boundary, very sharp boundary north of the Himalaya. And you see the Indian plate, the northern edge of Indian plate is sliced into so many pieces. And these are called thrusts and faults. And along these faults and thrusts, when there are movements, it creates earthquake. And most active part of the present day Himalayan fault is this one. This is called MHT, and that comes out here in the front of the mountain at the Shivaliks, or the Churia mountain in Nepal. Okay, so if you slice it, cut it inside the earth, just below Kathmandu, you can see how the Indian crust is being cut into pieces, and actually it's 2 pieces here. The MOES is much down here, and then you see a lot of these things are there. This is based on the seismic survey that we have done last 40 years. And this is more pictorial, that you can see the figure where you have a lot of these thrusts, and then same thing. And then you have the MHT, main Himalayan thrust, where the mountain moves along this direction, and then the plate goes below the Tibet, and then earthquakes occur. Most earthquakes occur in this place in the Himalaya, okay, about 100 kilometers from the front of the mountain. Nepal has a lot of seismic stations and also the GPS stations. Last 50 years, 40 years, this is what is Himalaya in Nepal. And you see how much there is no single inch where, the Nepal is safe or Himalaya is safe for earthquake. Every day there are 4 earthquakes occurring. And when you have big earthquakes, you have these big disasters. And also seismology is also together, it has to go with the GPS measurements. And Nepal has almost 40 GPS stations. These blocks that I showed you is run by Nepal Academy of Science and Technology, where I'm also the fellow there, and I have been working on these things. The rest is all Department of Mines and Geology. So we are monitoring the Nepal Himalaya with a lot of seismic stations and a lot of GPS stations. With this, we have come up with a lot of new data. For example, before 2015 earthquake, this was the situation. We put the GPS all along west of Gorkha, and that was the movement going on. You see, it was the 37.2, 39, almost 4 centimeters per year is the northward movement of Indian plate. But then, when you go to this region, the movement suddenly stops. I mean, reduces drastically, almost 7 millimeter per year. What happens there? It is just, it is not moving. That means it is moving up. So it is squeezed. And then this part is now strain built up will be there. So a lot of strain built up is here. The rocks are stressed. And when you have enough of energy where the rocks cannot stand, then you'll have a big earthquake. This is Pokhara and Kathmandu is here. You can see these are the things. So this was before 2015 earthquake in Nepal, Gorkha earthquake. And then we were telling you, see, here is the place where the earthquake is going to happen. And if you see today, all over the Himalaya at certain places, you have these strained areas. Now, this is where, the earthquake can occur. So what happens during an earthquake is like this. I cannot show you this animation. It's not working. Anyway, when there is an earthquake, you see this part is locked and this side is crypts. When the Indian plate moves, the storage of energy is here. And then, when big earthquakes occur, this whole yellow part will be going down. Otherwise, up to here is all storage of energy and it goes up. Sorry for this. It's something like this, above this line, this is like a spring. I'm just showing you the picture above this line. You see here, say Kathmandu Valley is here. It's like a spring. When this is after the earthquake, everything is relaxed. And then, once you push it, you see the spring goes like this. And then when you have the earthquake and everything moves, again, it comes back. So it is like a spring where during the earthquake, they are released and energy is released and big earthquake occurs. So about 2015 earthquake, this is the part that, Nepal part was moved. And this is how it happened. I showed you this MHT. You see here, there was the movement and the earthquake occurred here. 2 earthquakes were occurring actually at the time. And you see, this movement should have come all the way up to here, but it stopped here because energy was not enough. So for that reason, there is a lot of energy that is stored in the front of the mountain today. Only big earthquakes like 8 or 8.42, then only this red line will continue all the way up and comes out in the front of the mountain. So we have locked place now below south of Kathmandu where we are concerned about it can produce another 7 magnitude earthquake south of Kathmandu. What happened during earthquake during that time? You see, Kathmandu shifted 1.5 meters southward approximately. So the whole mountain has moved. So Kathmandu is not at the same place where it was. So if you go for the and then also at the same time, Kathmandu was uplifted by 0.74 or almost like, 1 meter high. Kathmandu was uplifted as well as the whole area. I mean, when I say Kathmandu, we measured here in Kathmandu. And this area was uplifted, but this area was subsided on the backside. What happened during an earthquake? One Kathmandu and one in the out of Kathmandu GPS stations. You see how they moved to the east, and then Kathmandu is more moving, and this area is still very quickly it has stopped. So Kathmandu Valley is like a jelly ball where whenever you have the movement. 1 minute, excuse me. Sorry for this. So you can see that GPS can give you live GPS, continuous GPS stations can give us such kind of information, which is very, very important. And we were lucky to have this station in Kathmandu and could see how it moved, our land moved, and at what distance, at what speed, up and down, and like that. So, okay. 2015 earthquake was not an expected earthquake that the geologists had, seismologists had predicted. It was not that one, but it is actually the one that we were expecting is a big earthquake that should be more than 8 or around 8 magnitude earthquake, either in the east or in the west. So that has not yet come. So that means the 2015 earthquake in Nepal is not the last earthquake. It has to come. So if you see the big earthquakes in the Himalaya, Assam earthquake 1950, many of you may know because it was much later and it destroyed a lot. Then Shillong earthquake 1897. Then you have 1934 Nepal Bihar earthquake. Then you have 2015 earthquake. Then Uttarakhand earthquake. Then Kangra earthquake and the Kashmir earthquake. So a lot of earthquakes occurring last 2 centuries. But actually, and this was Assam earthquake, it created havoc all the way to Shillong and further to your West Bengal. This is what happened during the 1897 earthquake. You can see a lot of damage was there in West Bengal. You see the railways and bridges, it collapsed. So this, another one was Shillong earthquake. You see, it had this red point is a red line, red zone. As you can see, there was a lot of damage all the way Dhaka and further west in West Bengal. We have a lot of fractures and faults, and this goes to Bangladesh, this goes to all the way to Calcutta side. A lot of faults are also here, and also the big earthquakes occur in this area. So Eastern Himalaya and Bengal, of course, further east is a very, very dangerous zone from the point of view of earthquake. If there is an earthquake in the Himalaya near, anywhere in the east, that will have a big damaging effect you see, this is another earthquake of Bengal, 1985 Bengal earthquake. I don't know how many of you know about it. At the same time, we had in Kashmir and in Bengal in 1885 earthquakes. A lot of damage was there, but not so many people died, but still, it was a big earthquake of 6.9 magnitude, not in the Himalaya, but right inside the plains. So we have to be very careful that, such kind of earthquake can occur also in the future. This is what I propose, like Eastern Nepal, Sikkim seismic gap, where we are now expecting big earthquakes here, which will be more than 8 magnitude earthquakes if that is the case. And of course, Western Nepal, all the way up to Dehradun, this is another place where we can have expect big earthquakes. What happens if you have that earthquake? What will be the magnitude? This is by Bilham. Recently, he published this one. You see that Sikkim 8.4, West Bhutan 8.4, Everest 7.8. All these earthquakes is going to damage in a big way in the plains in the south. So therefore, this is not a joke. It has to come anytime. It's only the probability when it will come, but otherwise it is already due. So therefore, we are concerned. So way forward, I wanted to close it my talk. So establishment of earthquake early warning system and continued research is the first priority. In Nepal, we are trying to do it, and we need cooperation, collaborations from all over, which is beneficial to both the countries. International cooperation for earthquake early warning establishment, massive public awareness and sensitization to the public, including school children and government machinery and local people, because preparedness is the only way. You can't stop earthquake. Renewed preparedness of rescue and relief operations. We are not very well prepared when there is a disaster. Then, you have been very good in India about the rescue and relief operations due to cyclones. This is a wonderful development that has occurred, particularly, since 1970s or after 2004 tsunami. And we are so happy, proud of it that, such a good work is being done whenever there is a cyclone. But when you talk about the earthquake, where is the preparedness? Where is the rescue relief operations? Where is the preparedness? This is what is really necessary, and it has to be done in a very, very quickly and very, seriously. Now, I just wanted to tell you that if there is an earthquake in eastern Nepal, near Darjeeling, what will happen? If you have an early warning system, we get about 30, something like 36, 37, 33 to 35 seconds of lead time. We can prepare ourselves during that time too. And if it is Kolkata, it is about 500 kilometers from here. You get about 83 seconds. So we can warn you that earthquake is coming. Please be prepared. So such early warning systems, if we can establish, that will be very good for eastern part. Similarly, in the west, we have to do it. Unfortunately, in India, they have not done anything so far for the early warning system for the entire Himalayan region of India. Nepal has also not yet done. We are trying to do it. We are trying to start, not yet started, but we have this concept of working on it. There was a small work in Uttaranchal, but then still I don't know how far. The Roorkee University was trying to do something. I have no information what is going on right now, but early warning system is a must in the Himalayan region if we want to save lives of millions of people. So this is what I wanted to tell you in very, very short period of time. I had only 10 minutes. I don't know how much I took it, but anyway, thank you so much for giving this opportunity. If you have any questions, I will be very happy to, answer. So be prepared for big earthquakes in the eastern Himalaya, and Bengal will not be spared. Don't think that we are far away from the Himalaya. Thank you.
Yeah, wonderful to have you, sir. It was so enriching our knowledge. We are really honored to have you, blessed to have you, really. And if there are questions, I request participants to pose the questions to sir. 2-3 questions we can take quickly.
Sir, I have one question.
Yeah, please.
Am I
Go ahead.
audible?
Yeah.
So, as you told that we cannot stop the earthquake, we can get the prayer, I think, 33 seconds.
Depending upon how far you are from the source.
Yeah.
That's the thing. That's very important.
So, what measures we have to take in order to mitigate the impact of earthquake on life?
Please, again, repeat the question.
So, what measures we have to take in order to mitigate the impact of earthquake?
Oh, there are many, many things that you have to do it to mitigate
Like
the earthquake.
major, yeah.
Yeah. Number one is, of course, you make your buildings strong enough, which will not be destroyed by the earthquake, depending upon where you are and how strong your house. That is very important. So in Nepal, we have started this building codes, which has to be very strictly done, very strictly enforced. Number one. Number two, how to be safe during an earthquake, after the earthquake, and before the earthquake. These things are, there are a lot of information available. Not only that, they also do the simulation exercise. They put the siren, oh, earthquake has gone, and then you have to follow the rules and regulations. This is done every few weeks or months in Japan, in Mexico. Every year they do it for the whole city. They do it for the whole city because Mexico City is also very prone to earthquakes, and in 1985, 10,000 people died, and there has been many such earthquakes have occurred there. So they have a very good system of this. Every year they have this exercise. A whole city is involved in that. So like that, we have those things. Then of course there are elaborate ways of doing it, and public awareness is very, very important, that you can have an earthquake, and when there is an earthquake, what you have to do and all that. So I cannot tell you all in details here, but this is an elaborate way of preparedness. So before the earthquake, during the earthquake, and after the earthquake. Early warning system is more recent things. Let's say about 20, 25 years before that started. Now, if you go to Japan, California, Taiwan, Mexico, or many other countries, Chile, they have all this system in place. It's very unfortunate that countries like India and Nepal and also Pakistan, where we have so much of death and occurrence and of course earthquakes, but then still we have not yet started this early warning system, and we desperately want to do it in Nepal, and then we are still struggling to start it because of the funding and so many other things. Thank you.
Yeah, thank you. Any next question? We can also quickly take one screenshot or a picture with our dignitaries. Kindly, can you just come on the screen quickly?
Who?
So that we can take a picture. Yeah.
Okay, yeah.
I request everybody to switch on their videos.
Yeah. My video is on anyway, right? You are muted, Dr. Jayashree.
Yes, we will
Yeah,
click
okay.
one picture quickly.
Yeah,
Yeah. Thank you. Thank you, everybody.
thank you.
Yeah, Geography department also will take because they have better sources than us. Technical, yeah. Yeah, tech support, please take picture of the session. And rapporteurs, please, yeah. Any other questions, please ask. We can ask next presenter. I think I have a visitor.
Yeah, one more question I'm having.
Yeah,
Please.
please go ahead.
Hello.
Yeah.
Yeah, as you told that post-disaster of the earthquake, it will be so difficult. So how to tackle with that post-disaster?
See, when you say
Because when the earthquake, yeah,
yeah, when you
because
say
when the earthquake will occur, it will, yeah, yeah.
okay,
When the
I will tell you.
earthquake will happen, it will block everything. So
Yes,
there will be no medical facility, there will be no food, there will
yes,
be nothing. So
yes.
how to tackle with that situation? Can we use
That
the
is what is
modern
the
technology like
preparation.
drones and something?
Yes, that is what is the
Yeah.
preparation. You see, you have to be well
Hmm.
prepared before the earthquake, that you train your armed police force or army or, whoever is the security forces. They are the responders. Similarly, you also train the local people. You see, the most important thing is whenever, you see, in 1950, for example, in Assam, there were very few people living there, and the houses were all wooden houses. Even if there was a big earthquake, it was shaking and then it doesn't. But things are different now. You have the concrete buildings. We say earthquakes don't kill people. It is the structures that kill people. You are in the house and house collapses and then it kills you. So therefore, the first thing is, therefore, your house has to be very strong, seismically strong, that I told you. But then the second thing is, once you have an earthquake, what happens is that you are already, under the rubbles. So somebody has to take you out and save you. And that is where is the rescue operation. That is mostly done by your own neighbors, your own families, whoever is available immediately, because it's very precious time. And then afterwards, when, the other external helps come from the army, from the police, now you have NDMA, you call it national, what do you call it? Yeah, they come very quickly. They have a very good system now. So they will come for your rescue operation. After rescue, then you have the, you have to, like they do it for your cyclone, that you have to put them in camps, you have to feed them for many days, then you have to give them shelter, temporary shelter. I mean, all these things have to be planned before. So like cyclone, they have been so well trained now. Same thing has to be done for the earthquakes. So training on earthquake rescue is a very, very technical thing, very highly technical thing. It's not just going to, during cyclone, you go with the boat, or, if it is a flood and like that. Here, it is very high-tech things. So, of course, in India, you have a very good trained manpower, but still there may be need more specialized people who will be trained in rescue relief operations during the earthquake. So I hope, sometimes I say India is so big, Himalaya is so tiny for India, right in the edge of India. Very few people live compared to 1.4 billion people. So the eyes of the whole of India is not really focused on the Himalayan region, but it's very bad. It's really, one has to think of that, Himalaya is so vulnerable. Every life is precious. So therefore, I feel that, the whole of Himalaya is lacking these efforts for the safety of the people. Think of Kangra, think of, so many earthquakes have occurred in the Himalayan region. Think of Kashmir, for example, more recent, so many people, 80,000 people died in Pakistan alone. And then, of course, you have also in Kashmir, Indian Kashmir Valley. I was there in Kashmir Valley in Islamic University of Science and Technology. I gave similar lectures there, and we talked about the earthquakes there. They are now very much concerned, and they are also trying to do something there. So therefore, local governments, I mean the state governments as well as the central government, has to do a lot of things on the research as well as search, rescue, and rehabilitation. Whatever, the cycle of disaster management for earthquakes has to be done. Thank you.
Thank you so much, sir. Any
Thank
other
you.
questions we have? We can go ahead with presentations. Do we have the dignitaries join? Can we take up? No.
Can we give chance, ma'am, to Riyaz Sharif as he's waiting?
Yes,
We'll
yes.
provide him
Please.
more 5 to 7 minutes.
Yes, yes, certainly.
Yeah, thank
We
you,
will
ma'am.
be happy to have
Yeah,
him.
yeah.
Yes, thank you very much, sir.
Yeah, Riyaz Sharif, please.
Thank you for giving me this opportunity. Thank you so much.
Thank you, sir.
I enjoyed talking to you. Thank you.
Thank you, sir. We are honored.
Thank you, sir.
Thank you.
Thank you very much.
Thank you.
We welcome the presenter.
Okay.
Yeah. Yeah, please, next presenter. Yeah. Yeah, let's have the presentation.
Hello?
Yes. Yeah, please go ahead. We will accommodate everybody. Whoever is ready, please start, because the order we are just, if there is some technical glitch, the one who is ready should present to save upon a time. It's 3:13, 3:15 now. So kindly, yeah.
Okay.
So please introduce yourself and take 7 to 10 minutes.
Yes, okay. First of all, I would like to thank everyone who contribute to success of this event. I'm Raja Habibullah from Morocco, from Laboratory of Geodynamics, Geomatic and Geotechnique, Department of Geology, Faculty of Science, University Kadayat from Morocco. Are you hearing me? Hello?
Yeah, you proceed, ma'am. We are hearing. You're audible.
Yeah.
Yeah, we can hear you, and your slides also can be seen. Please proceed. Thank you.
Okay. In this presentation, I will address an issue related to geotechnical aspects, particularly concerning the compressibility and tranquil soil behavior of clay soils in the coastal slope of Safi, Morocco. Through a geotechnical risk assessment, I aimed at effective preventive measures.
Can you go slideshow mode so that it is visible?
What?
Slideshow mode, slideshow.
Like this?
No,
Like this?
presentation. Yeah, this one.
Okay. The presentation will cover the following. First, the problem statement, followed by an introduction to the study area. Then we'll analyze the results obtained through various techniques used to characterize the clay formation involved in different types of instabilities. Finally, we will conclude with key findings. In the context of geotechnical risks, the Safi coastline is one of the Atlantic coasts most affected by a significant number and diversity of natural slope and stability. This poses a major risk to the safety of the population, the stability of coastal infrastructure, environmental sustainability, and sustainable development. Indeed, it is crucial to situate coastal slope affected by various geotechnical pathologies within their geographical context. These pathologies are evident in urban structure and construction founded on this clay formation. In, for example, Lalla Fatna site, there is expanding open cracks in road pavement, displacement and failure of retaining walls, translational landslide characterized by a planar displacement component of section of clay slope has been observed, causing the destruction of road infrastructure. Trees located in the path of the landslide have undergone significant tilting aligned with the slope direction. Also, rotational landslides are also very common, typically large in scale. They are visually identifiable on site as well as satellite imagery. Due to their extensive reach, they affect a significant portion of the cliff and are associated with the presence of brown clay formation. A detailed inventory also enabled an analysis of the spatial distribution and activity stats of this instability based on morphological criteria. However, the lack of historical data required the adoption of simplified classification into three categories, such as abundant latent movement, episodic latent movement, and intermittently active movement. It's therefore important to ask what drives such sensitivity and to determine the predisposing factor contributing to it. In this regard, sampling, company, and detailed laboratory tests program were conducted to better describe the mineralogical, geotechnical, and mechanical characteristic of brown clay formation and clay collected from the landslide areas. The result of physicochemical characterization of the slabs from different sites reveal medium to high plasticity, very fine grain size distribution with a high percentage of the fraction smaller than 2 micrometer. The grain size distribution range from clay to silty clay. The value of plasticity index, specific area, cation exchange capacity confirm their soiling behavior. The result of mechanical tests show odometer curves characteristic of expansive fine soils. The swelling potential is clearly detected in the mineralogical analysis. The spectra obtained for the clay fraction show characteristic peak of elite vermiculite and the presence of an stratification of elite vermiculite phase. All this result confirm the character of expansion of this clay. I will show you the flow chart for the adopted methodology, which outline different analysis and process steps to monitor the evolution of the coastline using the ArcGIS software and digital shoreline analysis system extension. The results from the tree statistical analysis show high variable mobility with general erosion trend. The highest accretion rates were recorded in areas suffering from complex mass movement phenomena such as landslide, rockfalls, collapse, and subsidence. In general, areas with high to very high accretion rates coincide with this showing intermittent activity, which contribute to acceleration of retreat rate in long of this course. Considering the soils susceptibility to shrink, swelling, and compressibility phenomena. It is crucial for effective risk management. Local authorities have implemented mitigation measures to reduce vulnerability by restriction damage infrastructure and introducing appropriate protective measures as part of risk planning and management in this area. Among the solutions adopted are earthworks, construction of retaining wall using gabion to ensuring the drainage, rock armoring to stabilize the slope, surface drainage for runoff water. And to conclude my presentation, this result provides useful information for coastal management, and insight is a key steps in linking the properties of clay materials to cliff change process, and considering that lithology is the major trigger factor of shoreline change and coastal failure. And thank you very much for your attention.
Thank you so much. Wonderful presentation. We have any questions, please post them. And I got to know from technical team that we are already in buffer time. So I've asked them to extend the time so that we can accommodate and do justice to all the speakers, remaining speakers. However, try to present the main points. All right. Yeah. Any questions?
I have
please?
one question to
Yeah.
one question to Habibullah.
Oui,
Is there
yes.
any lithology that is a major trigger factor for shoreline change?
Yes, it's the one of the other triggering factor, but lithology is the most or is the important trigger factors.
Okay.
There is
Lithology in terms of you are saying?
what's your question? Excuse me?
Lithology, how you are defining this is how you are defining the lithology is the major trigger factor for the shoreline change.
Because all the cliffs have important 10 formation of clay. The cliff where we have clay, they undergo all type of mass movements, but they show a high rate of change, of coastline change, and there is correlation between.
There will be the land surface changes. Have you not included that?
What?
Land surface changes are there. Have you not included in that? Land surface changes, whatever that is on the land that changes. Land surface change, like land use, land cover change.
Land use. There is an article that published in journals. I analyzed
Okay.
a lot of triggering factor, but I found that lithology the important factors, trigger factor that contribute to the landslide and all types of landslide movements.
Okay. My suggestion for you is you are doing PhD on this.
What?
You are doing PhD on this topic? You are doing PhD doctorate on this topic?
Yes, I had my PhD in these topics.
Okay. I will suggest you, if you want to extend on this topic, you just include the different things like land use, land cover, like the soil type in this. So it will be a good amount of research.
Yes, I have paper. I studied all the other factors, but the lithology is the major trigger factors.
Okay. Thank you very much.
Thank you for your question.
Oh, good. You can now leave.
Okay.
Ma'am, you can go for next.
Yes, next presenter. Yeah. Let me know if yeah, who's next? Shakti Kiran, are you there? Is there anybody who's left? I think Shakti Kiran is next.
Yes, ma'am.
Yeah.
I'm
You would
here.
like to take it up now?
Yeah.
Yeah, please. Please go ahead. We welcome you, sir.
Yeah. Hello.
Yes, please. We can hear you, but we can't see your screen.
Yeah.
Yeah. Yes, we can see now. Please go ahead.
Yes, ma'am. Check the screen once I change the slides, ma'am. Is it changing?
Yes, yes.
Yeah.
Yes. Good to go.
Yeah. Thank you, ma'am. I am Shakti Kiran, a research scholar from Shastra University, doing my PhD under the guidance of Dr. Kumar. I am here to present one of my PhD topic, which is the modeling of future flood risk under the climate change scenarios by integrating the HECRAS with the CARDOX REMO 2015 data. In recent years, there is a extreme climatological event due to the urbanization and the global warming, particularly in the Asia continent, have been facing the highest flood losses, flood fatalities and losses. Uh, UNESCAP in 2015 announced India as a flood-prone zone. Due to the last 4 decades, from 1980 to 2020, India is experiencing 235 floods and approximately 1.26 lakhs deaths and 1.93 billions of economic has been affected. So we need to consider the shifting patterns of climates for flood prediction and the flood risk management. By integrating the climate models and hydrological simulations, for assessing the future coastal flood risk. Hmm. So for that, high resolution of regional climate model data with the HECRAS models to predict the flood behaviors, the flood plains and rivers. So using that models, we get insights of flood extent depth for the flood hazard assessment. So this is my study area, which is in the east coast of Tamil Nadu, Lower Velar watershed, which covers an aerial extent of 965 square kilometers with a coastline stretch of 9 kilometers. This is a flood-prone zone due to its coastal proximity and the monsoonal impacts and the monsoonal rainfalls, and having a major water bodies like Vellara River, Perumal Lake, and the Paravanar Dam, and moreover the Neyveli Lignite Corporation is also alters in local hydrology and having a topography elevation of 0 to 154 meters, which is in the central highland and the east coastal areas. Like these areas are in the this is equal to mean sea level. And moreover, these areas are having the dense drainage network and having a high stream frequency, which is in a poor interconnectedness. So there is a need for flood management for the future climatic variability. Uh, and there are some traditional models. There is a research gap found between the traditional models and the future scenarios. So in this research, we integrate both of them by connecting the remote 2015 CARDOX data with the HECRAS model to simulate the future flood risk. So what is the outcome means? It will produce the insights for policymakers and urban planners for managing the coastal flooding. So there are three objectives. One is to calibrate and validate the HECRAS model using the historical floods, and to simulate the future floods by using remote 2015 and the CARDEX data, and to identify the flood-prone zones. The novelty of the research is the integration part between the future climate projections and the future climatic conditions and the traditional models. So this is my methodology. The research incorporates the DEM data which has been purchased from NRSE for 10 meters, and the LALC which has been mapped using a Landsat 8, and the soil data which has been collected from the Tamil Nadu Agriculture Department, and the river and the rainfall and the river discharge. Rainfall is one is from PWD and one is from IMD, and the CORDEX data. So the software we incorporated is HECRAS to simulate the flood, and Google Earth Engine to map the flood layers, and RStudio to validate the CORDEX data, the ArcGIS to validate and validate the model results and mapping the results. So once we move to the results, before we need to set up the model for a simulation. For that, we use the Cartosat DEM data for terrain setup, and LLC for managed coefficient, and the soil integration part for infiltration, and boundary condition. For internal, we use the river discharge data, and external, we use the cells which are near to the coastal areas for external, and for the rainfall. PWD has combined with the gridded data sets, IMD gridded data sets, and the model setup has been set for 100 to 100 meter resolution. For the time step, we performed a multiple trial and error method to optimize that 10 minutes is good for accuracy and its performance. So for the calibration purpose, we use a post and pre-event rainfall to enhance the model reliabilities. So this is the result of 2015, which is a past flood event happened in this study area. During the from the results, it shows that 236 square kilometers of the total study area has been inundated. And moreover, we already know that the water will move from the highland to lowland. So in this study area, the water is moving from west, which is northwest to southeast. And there is a linear stagnation in the southeast coast, southeast areas that shows that the paleo beach ridges and swells are present there, and there is a higher depths found in the central region, which is due to the waters or pumped during the flood event from the NLC mines. So we need to validate our model results. For the validation purpose, we mapped the flood layers from the RISAT image of 2015. We used the Google Earth Engine supervised part machine learning technique. Its accuracy comes around 0.94. So after that, we need to validate the flood extent and flood depth of the model results. So for that, we use the VGA data, volunteer geographic data sets, and the field observations. 96% of flood extent has been shown, and 90% of flood accuracy has been shown. And for the flood depth, we have collected our data sets from TN Smart website, which is totally dedicated to Tamil Nadu. This shows that the high correlation between the past and the simulated model results. So we use the validated model for the future projections. For that, the CORDEX data has been bias adjusted using the empirical quantile mapping. For that, p-bias, degree of agreement, and some of the statistical things have been used in a correlation in an RStudio. The results shows that the CORDEX data is good and fit with the observed data. So we categorized them into 4: 80 to 100 meters, and 100 mm of rainfall, and 101 to 150 mm, and 151 to 250, and greater than 250 mm of rainfall. This is based on the IMD classifications. So from the results, it shows that multiple areas have been affected in a future climatic conditions. In 80 to 100, the total area of extent has been increased to 266 square kilometers, which is more or less similar to 2015 flood event. And in the next category, 101 to 150 mm of rainfall, the area of inundation has been increased up to 309 square kilometers. And the moderate depths are identified around the central and the northern regions up to 0.3 meters. And then the next category, 151 to 250 mm of rainfall, the area of inundation is being increased up to 357 square kilometers. And the regions like Kamabram, Kurinjipadi, and the Kirapalayam regions are have been flooding under the depth of 0.6 to 1.2 meters. And it comes to the extreme very heavy rainfall, that is greater than 250 mm of rainfall. The total area of being inundated is around 458 square kilometers, and the depth, most of the regions are under the depth of greater than 1.2 meters, like the coastal region, like the urban areas like Neyveli and Kurinjipadi, and moreover to the eastern areas, moreover the southeastern areas like Parangipete. These areas are under the 1. And greater than 1.2 meters. The greater than 250 mm of rainfall triggers the dramatic shift in flood dynamics, leading to severe and catastrophic flooding. So, the conclusion part of this research is that the model has been validated and it shows the good results of accuracy. Using that, we gone for future projected conditions. So, from that, we got an insight that the extreme heavy rainfalls are lead to the severe floodings with a greater depths. And also, this research has clearly two SDGs. One is the sustainable cities and communities to reduce the number of people affected by water-related disasters and reduce the economic loss caused by the floods and other disasters. Using that, we have identified the urban areas which are prone for the floodings in future. One is the Neyveli near to Perumal lakes, and the lower elevation regions like coastal areas are prone to floodings. This is due to its local topography and the drainage patterns and the soil permeability conditions. And then the second SDG has been is climatic action. The strength and resilience and adaptive capacity to climate-related hazards and natural disasters in all countries. So in this, we have found that the areas which are under the prone, which are poor drainage conditions, which is need to be improved for flood infrastructure. And this study also provides a practical framework for flood risk management and to adapt the future resilience strategies. So there is there is also some research gap in this research. One is to use the high resolution data for continuous model validation. Right now, I have used 10 meter done now. So for the future scope, if we use a 0.5 meters or a 5 meter or less than a 5 meter, then we get a more accuracy results. So thank you.
If we have questions, please ask. Next, I'm asking Yusufullah sir, please be ready. I got your message. Sorry to have missed you. We couldn't connect with you. So please be ready. And if any questions, please ask quickly. We can take 1 or 2 questions.
If there is any questions.
If no questions, then can we move to the next presenter? We need to, because it's 3:45.
Yeah, I will
Yeah,
stop my
please proceed, ma'am.
Please, thank you so much, Yusufullah. So please join quickly.
Okay. Okay.
Yeah, we have. Yeah, please start presenting. We could see you. Okay. You can see your screen also.
Okay.
Yeah, we can hear you. We can see your screen. Please, we're good to go. Welcome you for your presentation quickly.
Thank you very much. My name is Yusufa. I'm from the Republic.
Kindly,
let me talk about you. My work,
yeah.
my work,
Voice.
my
Hello. Your voice is not clear. So please speak near the mic. Your
Yes?
voice is cracking. So please
Okay.
speak near the mic. Thank you.
All right.
Yes, better.
Can you hear me now? Like I said, this is one of my work about my PhD work. about the flood risk characterization and zoning in the meteorological area of Niamey and Niger. My name is Yusufa. I'm from Niger Republic, and thank you very much for this honor to give me to present you my works. Is about the flooding. As you know, flood is a natural event where typically dry land become submerged underwater, often due to excessive rainfall, river overflow, and dam failing. Flooding is a major natural disaster, and its frequency and intensity have been amplified by climate change. Variability in rainfall driven by seasonal change and climate shifts contributes significantly to pluvial and flash flood. Rivers, which are particularly sensitive to rainfall change, can cause fluvial flooding. For instance, the flood
ஏன்டா எங்க உள்ளது?
Yeah, Shakti Kiran sir, please mute yourself. Yeah, we're good to go, sir. Please continue. Hello? Hello, what happened? We missed you. Hello? Yeah, please rejoin. Hello? I think you got, yeah, sir, Yusufullah, you got logged out. Yeah, please continue, no problem. We can have you again, no problem. Please continue. Since I guess there is a technical glitch at your end, try to present the main points. Yeah, thank you.
Okay, the end of my study is to produce a update and accurate flood risk and hazard map for the study area. It is to identify the area at risk, the support decision maker, providing visualization and analysis tools to help decision maker and land use planning and risk management, to improving prevention and mitigation measures. And for the study area, we choose two study areas to compare them for our study. The first one is the capital of Niger Republic in West Africa, which is Niamey, at the hub at my left side. And the second one is Lokoja, which is calling the confluence of the two main river, which is in Niger River and Benue rivers. So in this objective, we use the multicultural analysis techniques to combine it with the GIS environment to produce the flood stability map and also the vulnerability map. We use actually nine criteria, beginning by the elevation to end with the type of flood. And for the vulnerability, we use three criteria, which one is the land use, land cover, the population, the total population, and also the total, and also the distance to the road. We combine the two maps, which one is the flood sensitivity maps and the vulnerability, to get the flood risk zoning. After the different criteria identified, we assign to all the specific factor a specific weight, which we can see in the two tables. The first table in my left hand is for vulnerability, and the table at my right hand is for the susceptibility. These are the maps for the different factors that we use for Niamey study area, and the second one is for Niamey is for Lokoja. And the thematic layer for the vulnerability, which I use here in the land use cover in 2021, the distance to the road, the population count, both for both cities to see the amount of the vulnerability that we have. And for the key funding, as the result, 32% of the region is at risk, with a high concentrate in lowing area. 26% are exposed to very high and in high risk. Lokoja also, we observe 15% of the region is at risk, with a high concentrate near river, very high and high risk area account for 41%. Flooding in these two towns is caused by a number of factors. First, we have the topography, the intense rainfall, the inadequate drainage infrastructure, and change in land use, land cover, such as the urbanization and the deforestation that is going to take higher consequences. The effect of climate change amplifies this risk, making flood more frequent and unpredictable. The risk distribution in Niamey moderately vulnerable area dominates, 31% actually, particularly in the center of the city. Otherwise, for the Lokoja, the risk is moderate through the region, with the area of low risk in the north and pockets and very risk in the south. This is the end of my presentation. Thank you very much.
Oh, thank you so much for this
Yeah.
brevity. We are very happy that you could finish because we could see there was a technical glitch. Thank you so much.
Yeah.
If there are questions, please post the questions. We have two more presenters, if not wrong. I think we have Mr. Chavan and the team, and Pranamika is the next. These two are left. I will call next as Chavan sir. But then, if there are questions, please ask. If there are no questions, then we will move ahead with the next presentation. Yeah. If any questions, please ask.
No, you can proceed.
Thank you so much. Yeah. So next presenter, Mr. Chavan, the team, kindly go ahead.
Hello, ma'am.
Welcome you.
Am I audible?
Yes, yes.
Okay.
Yes.
Shall I start my presentation?
Sure, sure.
Hello. My screen is visible.
Yes, yes.
You can go presentation mode.
Okay. Now it's visible now completely.
Yes, yes, yes.
Sorry. So, good evening, all. My name is Pranit Sawan. I'm from the Department of Geography from the Shivaji University, Kolhapur, and I'm presenting a seminar for the multi-criteria decision analysis with waterlogging risk mapping in Kolhapur city for the Maharashtra using geoinformatics approach. So I prepared this research under the guidance of the Dr. Prashant Patil and Vidya Chaugule. They are the assistant professor from the Shivaji University Department of Geography. So these are my contents which I am going to present in my presentation. That is the introduction, then the objective, then the study area, database methodology, and then some of the analysis, then the result, and finally we will go with the validation, how we validate our research, and summary and conclusion. So let's begin. Begin with the introduction. So urban water logging. So urban water logging refers to the accumulation of the water in urban areas due to the excessive rainfall, inadequate drainage system, or poor urban planning. It often leads to the temporary flooding of street, residential areas, and public spaces, which disrupting the daily life of people and causing damage to the infrastructure and properties. And the Kolhapur is one of the major city which is located in the Maharashtra state at the southern west, which has the waterlogging due to the monsoon rains. So it faces the waterlogging challenge during the monsoon season due to the insufficient drainage, then the rapid rate of urbanization and some of the vulnerable infrastructure. And there the role of the geoinformatics come with the help of the geoinformatics. We can identify the areas which are prone to the waterlogging and the flooding, and we can give the mitigation measures and assess the risk with the geoinformatics. So our research is aligned with the goals, aligned with SDG goals, that is the SDG number 11 and 13, that is the sustainable cities and communities, where we can suggest the mitigation measures and the climate actions, as the waterlogging phenomena is related with the climate, dynamic climate. So with the change in the climate pattern, the water logging risk also changes. So here we go with the our research objective, that is identifying the water logging prone areas with the help of multi-criteria data set, then generate the risk map to guide the urban planning and policymakers for the infrastructure management. And finally, we will validate our results with the ground survey and the municipal corporations of the local government, that is the Kolhapur. Then this is our study area map. So Kolhapur is located within the Maharashtra state of the India in the southwestern corner. So it occupies nearly 67 square kilometer, and the main geographical features surrounding the Kolhapur city, that is within the northern border, it is covered with the Panchaganga river, and inside there is a Rankala lake and Jayanti Nala, and around the rainfall range in the study area, it is around 150 centimeter to the 3001 centimeter. So this is our database and methodology. So we can go hand in hand with the database and methodology. So here for the database, we define the parameters and which is we categorized in the two main categories, that is the waterlogging hazard indicators, and the second one is the vulnerability indicators. So hazard indicators are mainly dealing with the environmental factors and the physical factors, and the second one, that is the vulnerability indicators, which are dealing with the humanitarian factors, that is by hazard indicators which threat the humans, that is we included in the vulnerability indicators. So we included 10 parameters in the hazard indicator and 6 parameters in the vulnerability indicators. So as you can see at the top, we have the data sources from where we taken the data, and the second, data processing. Here we classified the vulnerability indicators and hazard indicators. So in the hazard indicators, we taken altitude, slope, flow accumulation, and that is from the SRT MDM with the 30-meter spatial resolution, and the rainfall IMD graded data. Then from the Sentinel-2, we taken with the 10-meter spatial resolution. With the 10-meter spatial resolution, we derived the various indices like normalized difference, water index, moisture index, and vegetation index. And we also, with the next, we taken geomorphology and distance to rivers from the groundwater geological survey of India. Then the soil, we have taken FAO organization, that is the E3 shapefile type. Second, we taken the vulnerability indicators, that is the population and household density from a KMC, that is the local authority. Then we derived land use land cover from the Sentinel-2 satellite, then road network and education density and the distance to emergency services, that we mapped in the Google Earth Pro. Then we converted into the raster data set. So finally, we came up to the half of this methodology, and after that, with the help of the AHP, that is the analytical hierarchy process, in which we assign proper weightage according to the influencing parameters with the opinion of our expertise guide. Then with the help of various tools in the ArcGIS Pro, we combine these parameters, and we derive from the hazard indicators, we derived that hazard index map, and from the vulnerability indicators, we derived waterlogging vulnerability index map, and with the combining final two output, we created the risk map, and finally we validated our risk map with the KMC data and the ground surveys we done. So this is the weightage table. Here for the hazard indicators and vulnerability indicators, you can see the weightages which we given with the discussion with the expert. So in the hazard indicators, the distance to rivers plays a major role. So we given the higher weightage, and the geomorphology, it plays some minor role. So like that, we have proportionated the weightages, and in the vulnerability indicators, in the vulnerability indicators, the population density plays the major role. That's why we assign the higher weight to the population density, and the land use land cover with minimal influence. That's why we given the lesser weightage. So these are the results and findings of our project. That is, first one we will discuss with the hazard map. So where are the water bodies? There are more hazard to the water logging, and which is cumulative of the 10 parameters, 10 hazard indicator parameters, and in the vulnerability, who is more susceptible or who is more vulnerable areas, that is derived from the hazard indicator. And we created the map with the 5 categories from the very low, low, moderate, high, very high. So red areas indicating the very high areas with in the 2 maps, and finally with the compaction of the 2 maps and overlay of the hazard map and the vulnerability map, we created a risk map. So it is a combination of the hazard map and vulnerability map, where again we classified it into the 5 categories, and the areas which are showing very high in the red color, there we can see the very high risk of the water logging. And second map showing the additional, it is a replication of the same map, risk map, but here we added our water logging prone site, which we taken from the municipal corporation of the Kolhapur and our ground survey. So our most of our areas and the ground survey points mostly nearly matching with the our model output. So summary and finally I will conclude my research, that is the geoinformatics and AHP provide the actionable insights for the flood mitigation and water logging prone identification. And with the effective identification of the critical risk zones, we will provide this to the policymakers, and the same approach we can replicate in the other cities to minimize the human efforts and the similar challenges if we are facing in the other cities. The same model we can replicate there. That's it. Thank you from my side.
Thank you so much. We have Pranamika ma'am, if we want to present immediately, or if there are questions, please post questions for the presenter. Chavan sir, if you have any questions to Chavan sir. Hello, if any questions, please ask to Pranil Chavan if there are any questions for his presentations.
Yes, ma'am. I have a question, ma'am.
Yeah, please. Please, sir.
So, sir, your research is focusing on identifying the waterlogging areas, which means the lower elevations, right?
Yeah, low elevation.
So you have used the SRPM data, which is 30 meters. So using a 30 meter, the areas which are in the low lying are not properly visible to us. So how do you secure accuracy with real world?
So basically, we require the high resolution data. As of now, we prepared with the open source or accessible data from the SRTM mission. In future, we will work with the 10 meter spatial resolution, or we can say with the centimeter resolution from the cartosat. In future, we will going with that direction.
Okay. If you need open source, this is your PhD research.
Sorry, sir. I can.
This is your doctoral research.
I'm the MSc student, sir. Currently, I'm pursuing the course in the MSc Geoinformatics.
Okay. If you need it, you can use the person. This is the toll meter.
Yeah. Any other question?
Thank you. Thank you.
Yeah. If no question, please, then we have Pranamika, ma'am. Can you please present? We next.
Yes, yes,
Stop,
ma'am.
Yeah, please. Yeah, can you present? Because I think Javan sir is done with his presentation and I don't see second question. So are you ready? Can you go? Good to
Yes,
go?
ma'am. Yes, yes,
Yeah,
ma'am.
please.
Okay.
And after Pranamika ma'am, we can give the first presenter one more chance. Okay. So we can have Sharif sir after Pranamika ma'am. Okay. And then we will be ending it. Yeah. Thank you. Please,
Okay,
ma'am.
ma'am.
Go ahead.
Is my skin is visible, ma'am?
Yes, we can hear you very clear and loud, and we can see your screen.
Okay, ma'am.
Good to go.
Okay. So, good afternoon, everyone. So, our research topic is mainly spatial and temporal patterns of river bank shifting of Jayabharali River, Assam, India, using remote sensing and GIS technique. So, this is a table of contents for our study. River channel shifting refers to the natural and human-induced movement of rivers course over time. The main causes of channel shifting include changes in the land cover, severe flood, and weak geology. To understand the river's current and future behavior, its changes are observed over time. Using high resolution and satellite images, we can track changes like shifting river courses, formation of oxbow lakes, new channels, formation of new channels, erosion and deposition of river banks, providing detailed insight into the river morphology. So our research objectives is to uh, find out or comprehend the evolving conditions of Jayabharali River over a specific time frame, focusing on the rates of erosion and deposition during the study period from 1990 to 2023. Our study area, Jayabharali, is one of the main tributary of Brahmaputra River that flows through the center of Sonitpur district of Assam after falling from the lower Himalayas in the Arunachal Pradesh in northeastern India. The Jayabharali River is also known as Kameng River in Arunachal Pradesh and has a significant geological, economical, and cultural significance for the region, supporting the diverse ecosystem and communities that can rely on it for agriculture, fishing, and transportation. The river carries a significant sediment load from the Himalayas, contributing to riverbank erosion, changes in the river morphology. So this is the location map of our study area. Data use and methodology for our study. For our study, analyze the Jayabharali River channel shifting using satellite images from 1990, 2005, and 2023, selected mainly cloud free quality. Data sources included USGS satellite imagery with 30 meters spatial resolution and supplementary maps obtained from the Survey of India website. So we mainly use remote sensing and GIS techniques to study the riverbank shifting, erosion, and deposition trends. So our main focus is to understand and monitor the river dynamics over the time. So this is the conceptual frameworks of our study. So first we took the Landsat TM and OLE image. Then we process the image and classify the image, and from that we extract the river layer, and from that we generate the output, and ultimately we analyze the output. Results and discussion. So lateral channel shifting, which also threatens the channel's instability, is one of the most prominent characteristics of alluvial river course, lower course rivers such as Jayabharali. Jayabharali is a dynamic river with steady channel shifting tendency. It is a major tributary of Brahmaputra River, flowing through the Indian state of Assam, and is known for its significant channel shifting, a phenomenon where river changes its courses over time due to natural factors such as sediment deposition, seasonal floods, and erosion. Channel shifting from 1990 to 2005. So from this map, we can observe that the mostly rivers shifted westward direction during the time period of 1990. At this time, the upper and middle portion of river were wider and braided. So we can see here that in the upper and middle portion it was much more wider and braided, but in the lower portion it is narrower. And in 2005, the river shifted westward. Here we can see that river shifted towards westward, and in the middle part it bifurcates into many channels and again joins in the lower part. So the erosion and deposition rates between the time period 1990 and 2005 were 1085.12 hectare, 741.02 hectare, and the uncensored area was 72.83 hectare. Channel shifting during the time period of 2005 to 2023. So from this figure, it is found that in the period of 2005, the upper part, here 2005 is denoted through blue color. Here we can see that in the upper part, the river was wider and narrower in the lower part. The middle part of the river is divided into two channels because of high amount of sedimentation. Here we can see that river is mainly divided into two channels because of the sedimentation. In 2023, the upper part of the river shifted from the east to west, and in the central part, it again shifted towards the eastern part. In the lower, again, it shifted westward. Here we can see that it shifts towards westward, and it is observed that river was more braided in its upper part, and it becomes narrow from central to lower part of the river. So the erosion and deposition rate between time period 2005 and 2023 was 612.51 hectare, 601.69 hectare, and the unchanged area was 201.34 hectare. So this is the table showing land area changed by erosion and deposition during this time period. And this is the graphical representation of our area, study area. So here we can see that during the time period of 1990 to 2005, the erosion and deposition was very much higher in comparison to 2005 to 2023. And also the unchanged area becomes increased during this 2005 to 2023 phase. So in conclusions, we can say that understanding river channels shifting is essential, and studying how rivers path changes is important for reducing risk and protecting the environment. Over the 33 years from 1990 to 2023, the Geographical river's path has shifted a lot, and our analysis shows that Geographical river is not stable yet. So this means the river is still changing, and in the future there will be likely to more sediment building up in some areas and erosion in some others. So these are the references of our study. With that, I'm concluding our presentation here. Thank you.
Yeah, thank you. Yeah, any questions for her? Quickly, can we have some questions? Because I'm sure Sharif is waiting eagerly. He'll be presenting again. Sorry, Sharif, so much. Sorry. Yeah. Any questions for Pranamika? Any questions from rapporteur? Any dignitaries? Any participant? I guess there is no response. Yeah, Shakti. Shakti Kiran has some question, I guess. Please go ahead, Shakti. Yeah.
So we can move to the next person.
Yes, Shakti Kiran, you have question, it seems. Please ask. Sharif, ready? Next. And I think last presenter. Have we missed anybody? Please check. Shakti, oh sorry. Shakti doesn't have a question. By mistake, he popped up. His window popped up. Okay. So we can have, I think because of that, then it seems there are no questions. So we can proceed with Sharif. Sorry, Sharif, we had to wrap you. Please take 10 minutes and continue.
Yeah, Ria Sharif is there.
Yeah,
We can hear you. Yeah, please.
you can see my presentation. Right?
Yes.
Hello. I am. Yeah.
Yes.
Yeah.
Yes, we
Also
can.
so my topic is thank you for presenters and the participants and the people giving me another chance, and thank you for that. So my topic is investigating the interplay of land surface temperature, NDVI and NDPI on nitrogen
Yeah, you
dioxide
can
and carbon
skip
monoxide.
the initial slides. Sorry. You can skip the initial slides because I think we heard you. Now, the whatever you want to
Yeah,
present.
let me go to what. So these are the table of contents and introduction to such objective data sets, methodology, research, and conclusion. So I have done my introduction part, and this is my study area, Kolkata City. And for the bivariate analysis, we'll be taking the Kolkata's Lok Sabha map for pointing at the locations in the later period. And these are the research objectives. We have four objectives: how the NO2 and CO concentration, spatially and temporally, spread across the study area, and how the impact of rising land surface temperature make an impact on pollution, and how the vegetation cover make an impact on pollution, and at last how these all factors play a role in urban planning strategies. So for the data sets, this data primary goes with the satellite data. So for the data sets, for nitrogen dioxide and carbon monoxide, we have used Sentinel 5P data of a tropospheric monitoring instrument. And for land surface temperature, NDVI and NDPA, we used Landsat 8 data and for with 830-meter resolution, and the whole analysis have been done using Google Earth Engine. So methodology, we have used two statistical analysis, bivariate analysis, and a linear regression model for the for my research. It's been used with the R programming statistic tool. So for bivariate analysis and linear regression model, bivariate analysis is essentially a statistical mapping area where we see the relationship between two distinct variables. So, our one part of the variable will be air pollutants, NO2 and carbon monoxide, and the other part of the variables are LST, NDVI, and NDVI. So, we will be applying this bivariate analysis to see in which locations this pollution and the environmental variable LST, NDVI, NDVI act. So, spatially, we can locate which area is high, which area is low, and which area which has both environmental variables, how they are acting in that area. So linear regression model are used to statistically show the
Hello.
relationship between.
Hello. I'm audible. Hello.
Sorry.
Sir,
Yes,
I am
please go
audible.
ahead. Yes.
Sir, basically we have time over time already. Please wrap up and finish this session.
No, I didn't got a chance to explain first, and again you are making
Yeah.
suddenly.
See, Riaz. Yeah, fine. You continue, and then we will. Sir, this is the last presenter. Okay, so just
Okay,
another two
but
three minutes. Okay, and we are done.
okay.
Yeah, last presentation. Yeah, we should give justice to him because we had to. Yeah, please.
Ma'am. Okay,
Yeah,
ma'am.
please, Riaz, go ahead.
Okay, so this is the result, statistical result I got for NO2, nitrogen oxide, dioxide, carbon monoxide, land surface temperature, NDVI and NDVI. So in these years, we can see during the COVID time, 2019 and 2020, NO2 is quite low, and 2021 it got a pretty high peak. We'll be seeing the peak area of that time, or 2021, and subsequently we'll be seeing the highest of NO2, and same will go for carbon monoxide. In 2019-20, we see quite less comparing to 2021. And in land surface temperature also, in that period, we seeing the lowest, it is 26.941 degrees Celsius, which we got it around 2020. And for NDVA also, it's like same procedure happened. And we're going to the next part, we'll be showing the maps I've analyzed. This is for 5 years, which is 19, 20, 21, 22, and 23. So I notice you NDVA and you are can able to notify in that map. This is the main part of the result. This is the scatter plot I got. This one shows the how NO2 is acting with LS. So if you see the trend line, it is actually showing the positive correlation, which means that LST has a positive correlation with NO2. So if LST is increasing, so NO2 will be increasing. So there is a relation that temperature is acting on NO2 in these urban areas. And if you see the NDVA part, vegetation part, we see the negative correlation where the trend line is showing a downward angle, which means that NDVA is not supporting the NO2, and because the urbanization part doesn't have the vegetation cover. So if the NDVA is low, the NO2 is high. So this shows that we need urbanization needs vegetation cover to absorb this air pollutants. In part of NDPA, this is the main part we built up index. We know that Kolkata is a very dense populated area and urbanization very dense. So we can see the consistent trend of trend line uplifted, and so it shows that the urbanization plays a major part in this NO2 pollutant. So subsequently for carbon monoxide, rather than not like nitrogen dioxide, carbon monoxide actually plays a downward angle in LST or a mid angle for LST. And for carbon monoxide, same like NDVA, this also plays a downward angle, or the we can see this consistent of values are not prominent like NO2. So, and the NDPA shows that in both part NO2 and CO, NDPA plays a major role. So that urbanization is the part that makes both the pollutants increasing in that area. So this is a bivariate analysis map which I've done in using R programming, which shows which areas have a high NO2 or a high environmental variables like LST, NDPA, and DPA. So you can see dark green area. It shows that high NO2 and high LST area at the Kolkata north side, and high NO2 and low LST we can be seeing that in middle part and quite north of Kolkata, and low NO2 and high LST in the eastern part of the side, which actually comes with the north part of Kolkata, and we can see low NO2 and low LST in the far side of eastern Kolkata. So this actually shows like how the spatially these variables are spread at, and which will be useful for the government to notify which areas we can concentrate more. And for NDV also, we can see that high NO2 and high NDV makes note that how vegetation cover is very low in that area, so which makes the pollutants very huge. So in subsequent years, if the vegetation is getting really low means, then the pollution will be high and it can't be stopped. So NDPA, this plays a major role. So it shows the urbanization of Kolkata. So major urbanization is actually in the central and northern part of Kolkata. It shows that high NO2 and high NDPA in that area, and low NO2 and low NDPA shows in the eastern side of the Kolkata, which is not having pretty much urbanization like the central or north part of Kolkata. So this was the same like nitrogen dioxide, carbon monoxide also shows like that, but carbon monoxide actually spreads very distributed to whole areas. That's the nature of carbon monoxide. It spreads more than nitrogen dioxide. So you can see high carbon monoxide and low LSP in the western side of the Kolkata, because there is Hooghly River which passes that area, and we can see high CO concentration, high LSP in the western part, but it actually comes to the south part of Kolkata. So the next, so in this we can see the vegetation, how vegetation takes a part for both the pollutants. So in the third one, we see CO and NDPA. So urbanization is the major problem in this. So we have to take actions for that to decrease this. So these maps will make the government or NGOs or the people or the researchers to notify which areas we have to concentrate more and which areas will be prone in the future. So as a result, I've already told my result with those maths and statistics. So as a conclusion, we have to have 5 major points to be addressed, which shows the integrated urban planning. So with the urban planning, we can able to reduce this air pollutants with the proper planning of government, and all the people also have to take a part in which public awareness comes into the action, because public awareness is the main thing. People should know they also have a part in this. So then the emission control measures, we have to make a strict regulation on the vehicle pollution. We have to promote the public transportation, and in which the technology also plays a part where we can know, like proper monitoring has to be happen. So the data should be there for 24/7. So we can actually give more, we can get more knowledge about the pollutants happening in the city. So that should be an importance for vegetation too, because vegetation observes pollutants. So wherever part we can able to uh, uh, concentrate to improve the vegetation content inside the city, we have to take that measures. So we will be getting an idea of like whether we will be like whether this happened. That is an example for these measures. Yeah, there's an example that China did it with the motto of war on pollution in 2013, in which Beijing was the biggest polluted emitter. Likewise, Delhi now. So they have taken measures and from 2013, and they made 42% drop in the Chinese cities, and in which Beijing plays a 50% drop in air pollution content, in which they made an idea of making public transports, making everything electrical, and going from biggest coal consumers and biggest carbon emitters to renewable energy producers. They are spending more on that. The government is spending more on the economy, so the economy will also grow, and the people will also will be safe in the environment. So at last, I have to tell how the climate change, as we have to act for the climate change. So this motto have to be priority. So action for climate change is not a choice; it's a necessity, because we are in that period right now. We are seeing right now that Delhi is being the most polluted part of the world, and we have to take action. And we should not be have a choice about it. We have to act about it. Only then we can able to give, bring a solution like what China did for Beijing, and we can't do for Delhi. But by not saying that okay, it's done, we can't do anything about it. We can do measures, right? We should not be taking. We should take necessary action for it. Thank you.
Yes, thank you so much.
Thank you.
Yes, any questions for Sharif? Yes. Yes. Any questions, please? Is there any other presenter would like to speak or add something or ask questions? Because this is the last presentation. We just need to propose the vote of thanks and we can end, because the technical team is eagerly waiting for the session to end. Yeah.
No other questions, ma'am. I just need to tell you that thank you for coordinating us.
Oh, thank you so much. Thank you so much.
It's a long thing now. Thank you.
Yeah, I mean, we couldn't have all the technical, the lead and session chair and co-chair. Sorry, I don't know what
Yeah,
happened.
yes, ma'am.
You can
Thank you for helping.
proceed, ma'am. You
Yeah.
can
So
finish. I think there
we
is no
can,
question.
yeah. Thank you so much. Thank you so
You can
much for
finish.
your college and for this international seminar of this level, and having a really great time. And it's an honor to be part of this seminar. Yesterday we presented, and today I had to coordinate, and we could do some crisis management. I'm so thankful to have wonderful presenters, wonderful human beings who tolerated us we throughout the time, and this juggling and all that. But we are successfully through. Thank you so much, the moderator also. Thank you each and every participant. Sorry for any flaws. Yeah, and then we will certainly meet sometime. Thank you very much. We end the session here. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank
How to end the meeting?
you.